So hello everyone, we are back with the new chapter of number theory. Today we are going to do this chapter of number theory. You might be thinking, yeah, it's what kind of chapter? It's all about numbers. It's all about numbers. So everything. Why do we need to learn about numbers when you know everything about them? The truth is that not about the numbers. It is the behavior of numbers. It's about the behavior, how they behave in it. Okay, now plus number theory, we have plus number theory, we have PNC, we have a place. It's kinda, what is this? What happened? Oh no, I don't know what happened. Just see, it's about not about numbers, it is about the behavior of numbers. Okay, now it is not that important. You might be thinking, why do you not how behave? One behaves as one only, two behaves as two only. No, it's not like that. Okay, it's about how they behave. We are following a plan. After number theory, we'll do PNC. You know PNC as combinatorics, combi or permutation and combination, permutation and combination. And after that, we'll do CRT. CRT is Chinese remainder theorem. The theorem. You might be thinking, what Chinese remainder theorem? We're doing it here only. Here it is written Euler's remainder theorem. Then Euler is from China. No. Euler is not from China. Okay, this is one kind of, this is another kind. Okay, this is very important. In every type of exam you give, this chapter is a must. The number theory, CRT, PNC. PNC related with probability, will do that too only. So starting with, we have started with our number theory. Then we'll do PNC, then we'll do probability, as it is directly related with PNC. Next we'll do CRT. So what are the things we are going to do in number theory? Here it is written. It is written as our Euler's remainder theorem and congruency theorem. Today we are going to do these two things. Okay, the Euler's remainder theorem and the congruency theorem. These are very important in every type of. Now notice its importance of this chapter in every type of exam you give, for bank jobs, JEE, IOQM, IMO, accountancy exams, IAS, IPS, that is UPSC, any type of exam you give, it's very, this chapter. What happened? What is this? Okay, UPSC. UPSC is very. What happened? What is the writing of number theory? Oh god. Okay, let me write it here. Number theory. Where has it gone? I don't know. Number theory. Here it was written as our Euler's remainder theorem. theorem, and here it was written as our congruency theorem. Okay. Let's get started about. You are getting these as notes, that's why I just like the world is very wrong. Okay. Yeah, now see. PNC CRT, the Chinese remainder theorem. Very important things. So this is our serial, remember, number theory, PNC, probability, CRT, and this is our the exams for where it is very important. At least two questions you'll surely definitely get. Okay, so let's get started with everything. Yeah, correct. Yeah, Euler's remainder theorem. When we were kids, we learned something known as this: dividend equal to divisor into quotient plus remainder. Do you remember this? Just tell me, do you remember this? Dividend equal to divisor into quotient plus remainder. Today we'll write it as A equal to BQ plus R. And this is what is stated by Euler only. Euler here states a very simple thing: A is always greater than B, greater than 0. And of course, yeah, A can be equal to 0, A is greater than B, A is greater than 0, and B is anyways, as it can be written as A by B, and B can never be 0, and A is greater than B. The R ranges from 0 to B minus 1. R ranges from 0 to B minus 1. Yeah, B minus 1. Divided by B minus 1. And R is always integer. Z positive integer value. Simple things, simple tasks, simple reasonings. Okay. Understood? Now these are the conditions. Please note down these conditions, it may come in the exam. Let's move on to the first question. Given that, find the quotient of a number whose dividend is 5 times greater than its divisor with a remainder of 5. Find the quotient of a number. Find the quotient, not of a number. Find the quotient whose dividend is 5 times greater than its divisor with the remainder is 5. Let divisor equal to D, dividend equal to 5D, then 5D equal to quotient be equal to Q, 5D equal to QD plus 5. Then from here what you get, the value of 5 into D minus 1 by D is Q. But we won't get an accurate value here, we only need to express it in terms of D. Okay, that was a very simple question. Oh god, what is this happening in this world? Well, let us write here the solution again. There is the number 3 is not there. Okay. Congruency theorem. Everything has got erased. Okay, never mind. Sorry. Here we're written as let me write divisor as d, dividend as 5d, as it is 5 times greater than the divisor. 5d equal to quotient is q, qd plus 5. Then here we get 5 by d into d minus 1 equal to q. This is our answer. Okay. What is this? This is our answer. Very simple questions. At last of the chapter, we'll do a question session. Then we'll discuss some very really tough questions. Congruency theorem. Now, congruency we have studied in. Oh, sorry. Congruency we have studied in triangles geometry. Congruency is there in arithmetic. Number, it means the number 5 with the number 6. How are they congruent? It has 1, 2. It has one straight side, one curved side. It has one curved side only. Therefore, 5 is not congruent to 6. No. This is nothing. This is not correct one. This is not this congruency. Congruency of a number states that, let's take 23 divided by 5. It gives us 4 with the remainder of 3. How do we write this? We write it as 23 congruent. Congruent is this. You know, this sign is actually of what? This sign is actually of equivalent. Equivalent. Okay. Keep it aside. What's this? What's happened? Okay, therefore it. Okay, it has gone behind. Okay, it goes behind. Oh, it can movable. I can move it here. How can this be happening? I don't know. Keep it here. Okay. You might not be able to see. Yeah, now it's correct. If 23 congruent to what? What a freaking thing is this? Oh, never mind. 23 congruent to 3 mod 5. See, mod, this mod of 5 equal to 5, mod of minus 5 equal to 5. No, not this mod. This mod is known as modulo. This mod is known as what? Modulo. Okay. We write it this. This is our congruency theorem. Then we write anything like, what's this? Huh. I don't know. Okay, so okay, it's the problem. Yeah. Now you know it has some properties. It has our many kind of properties. Let's see. If you apply the power of 5 here, it is given to you like, find the remainder when 23 to the power 23 is divided. Yeah, I have an idea. I will do the problem and you will understand all the basic features of it. Let's do it. This is basic. The problem states that find the remainder when 23 to the power 23 is divided by 5. Manual start calculating. 23 square, 26 square. Then we multiply it by 23. Then not like this. We are very good, clever students. We know everything, how to do anything. Let us solve it. Oh, what? Yes. Let us solve it. My screen blacked out suddenly. See, we know 23 is modulo 3 modulo 5. We apply the power of 5. We can apply the power of 5 here also. C to the power 5. Yeah, both sides. This one property, that A congruent to B mod C, if it is like, then A to the power M is congruent to B to the power M mod C. 3 to the power 5, we know it as 243. Divided by 5, we get only 3 only. 3 modulo 5. We take the power of 4 again. 23 to the power 20. 5 4s are 20. A to the power M whole to the power N equal to A to the power M. And if you forget this, then leave studying. 3 to the power 4 modulo 5. But 3 to the power 4, remember, 81. 5 1 divided by 5, it gives 1. 1 modulo 5. Mod 3. 23 to the power 23 into 23 cube is directly congruent to 23 cube to modulo 5. Which property we get here? A is congruent to B mod C modulo C, then A into M congruent to B into M modulo C. Yeah, that's a very good one also. Let's solve. You might be saying 23, we have to do 23 cube. Oh no. No. We apply the property, distributive property. 23 square mod 5 into 23 mod 5. You might be saying, yeah, we can do this also, the distributive property. That if A is congruent to B M mod C, then we can write it as B mod C into M mod C. All these properties are here only. Okay, just check the PDF. I will share with you. Here 23 squares can be written as let's do the calculation. 23 square, 23 is 9, 3 to the 6, 3 to the 6, 12, 12, 2, 5. 529. I think 3 is 9, 3 to the 6, 12, 12, 12, yeah, 529. You might be thinking, how did I do it in one line only? I have a video. Check it out. 529 when divided by 5, it gives us as 4. 4 modulo 5. Into 23, it's 3 only. Modulo 5. And when it is multiplied here, now we can, the ulta of distributive is our distributive property. We can write it as reverse. Reversing it, we get 12 modulo 5. Dividing 12 by 5, we get 2 modulo 5. What's the answer? You know. The answer is 2. Answer is 2. Very good. You feel a relief of satisfaction. You feel a feeling of satisfaction when you do this. You know. Just see the way I've done it. It's so nice to do. Let me see if I'm talking all alone or if the recording is going on. Yeah, the recording is going on and I'm very happy with it. Yeah. See. Sorry. Now see. Okay, just see the process. Everything. 23 congruent to 3 modulo 5. 23 to the power 5 is congruent. Just see. Notice this part. How can I select it? I can go. No. Oh. Yeah, I just was suspected. And I'm happy that it's not here only. Now I can select. I think so, yeah. Now this part. Oh god. Yeah, from this part. You know, I'm doing this lecture on Nokia 3310. No. Never mind. I'm not that bigari. Let me just select it. It doesn't work sometimes. Yeah, now it worked. Let us wait. Yeah. Let me mark it as red, pink, blue, white, green, blue, white. This part also. Never mind. We'll just erase this part. A is congruent. Now we'll apply our big box. I'm a mark of the star boy. Have to move it bit by bit. Okay, let me just copy this part. And I'll then paste it in another page for you. Just notice the patterns, okay. And then, now see. Let me add a page there, and then we'll paste it here. Here are the formulae for you. Oh god. Yeah. Disappear. Done. Happy? Yeah. These all the properties are the property of congruency theorem. Properties of congruency theorem. Very important, you know. Congruency theorem. Now, you must have understood with this problem. Anything? Not understood. Never mind. Check other videos. Sorry. If it's there, it's not there. Okay, never mind. Check whether it is divisible by 7 or not. Let me move to this page. You might not have understood this one only, and I've done so many things with you. Just understand this part. That 3 is the remainder here. It's the remainder. This is our divisor. And this part is our dividend. Okay, this is what is everything. Congruency theorem is limited to this only. This is our. We left it. Let's move to this part. Check whether this is divisible by 7 or not. Can you think of something better than everything? Yeah, about girls. No, not that type of thinking. Girls be like, okay, leave it. See ya. Check whether this is divisible by 7 or not. Just think. 12 is divisible by 4. When 12 is divided by 4, what's the remainder? Huh? When 12 is divided by 4, what's the remainder? 0. That is, if this above number is divisible by 7, then the remainder must be 0. We have to find out whether this number is 0 or not. In this part, I am reminded of a very good thing about congruency theorem, which I did not explain to you. During the process of doing this problem, I'll explain to you. If you want, try it now. Okay. If you want, try it now. Let me start. Okay. Starting with this part. 5555 to the power 2222. We have to prove that it is something A or not to leave it. That is 5555 mod 7. We first wrote this. When this is done in the processing, it will come as same only. Okay, let's come. 5555. Let's dividing on with 7, we get it as 7 square 49, 65 7 and 63, 25 7 is 21, 4 modulo 7. Okay. Now remember, this is the real problem. Okay, we'll add to this. Now we square this. We have to square this also. 2 modulo 7. How? 4 square 16, 7 to the 14, 16 minus 14 is 2. Then the remainder is 2 only. Then next part, we have to move on step by step. Okay. Okay. That's 1 1 1 1 remains. This multiply directly? No. How can I do it? Okay, let's multiply. 1 1 1 1. Sorry. 2 to the power 1 1 1 1 modulo 7. 2 to the power 1 1 1 0 into 2 modulo 7. If I get a 7 here, well, I'll get a very nice thing. For these problems, we need a thing called as FLT, the Fermat's very little theorem. Fermat's little theorem. Fermat's very little theorem. It states that e to the power n minus 1 is congruent to a modulo n. I'm wrong. Sorry. I was thinking, what's happening all around? Oh, it will go away, vanish. Fermat's little theorem is not like that. Yeah, guys, I went to drink some water. Oh my, yeah. You see, it states that if a to the power m minus 1 is there, then it is directly congruent to 1 mod m. Case is that HCF of a comma m is 1. Okay. You can see 2 and 7 are co-prime. That is there. HCF is 1. Therefore, I can apply this here. Means I need 6 into something plus something. Something plus something? Yeah, something plus something. We'll learn in the next lecture about this. The Euler's theorem, the Fermat's-Little theorem, the Wilson's theorem, and the. Now for this problem, especially I will use this one. Let's divide 6. 6, 1, 1, 1, 0. 6 1, 6, 51, 0, 6, 6, 7, 42, 6, 8, 48. 51, 6, 8, 48, 30, 6, 5, 30. You can see 2 to the power 185 whole to the power 6 into 2 modulo 7. It will just cancel out 1 from here. You might be thinking, how? Have we not used here the. Where it is gone? Yeah, here. Huh. Here the. What is this called? I forgot the property name. Okay. This property will not the. Okay, I forgot. Means the multiplicative where we differentiate B mod C into M mod C. See here. We can write it 2 to the power 185 6 mod 7 into 2 mod 7. Yeah, of course. Now see, is it not like this? Let me write it in this format. The 2 to the power 185 whole to the power 7 minus 1 mod 7. It's not like that only. You might be thinking it was there. In fact, if it was there, then we take it that side and it will be 1 again. We take it that side, yeah, of course. 2 modulo 7 mod 7. The Fermat's-Little theorem, I'll just keep it here. You may make it in the box. It's very important again. So great. Yeah. Fermat's-Little theorem. It's very little, but it's very effective. See here, it just converted this whole part to 1 only. From here it comes 2 modulo 7. Any calculation mistake, please pardon me. I don't know. Okay, I'm very bad at calculations. Next part. So therefore we get this as that 5 whole to the power 2 is directly congruent to 2 modulo 7, means it has the remainder 2. Yay. Let's move on further. Next part. Right. What is this? Euler's torsion function. Nothing. What's there? Hey, what's happened? Yeah. Plus. Minus. Hey, no. What? Okay. Comes out 2 modulo 7. Same procedure will follow here. 2 modulo 7. First and foremost is there. We'll write it down there. 7 to the 21, 12, 7 752, 7 to the 49, it's just 3. 7. 5 to the power 5. 3 to the power 5. 32. Not 32, 243. Dividing it by 7, 33. 6 modulo 7. I think so. Most probably it's 6 modulo 7. No, it's not 6 modulo 7. Yeah, 3 to the power 5 modulo 7. Now, 2 to the 243. 243 divisible by 7. 7 to the 21, 33, 7 for the 28. 5, yeah. 5. It's 5. 5 modulo 7, same thing, to the power 1, 1, 1, 5 to the power 1, 1, 1, 1, modulo 7. Here comes our 5 to the power 1, 1, 1, 0 into 5 modulo 7. You might be thinking, yeah, we got it again. Yeah. Oh, I got 4, 4, yeah. Again, it's 5 to the power 185 whole to the power 6 modulo 7 into 5 modulo 7. Very nice thing we got again. This part is repeated here. Yeah. Again, this goes out with the 1. And we get 5 modulo 7. The addition allows us to add them. Now here we get as 5 to the power 5, 5, 5, 5, 5 to the power 2, 2, 2, 2 as 2 modulo 7, 2, 2, 2, 2 to the power 5, 5, 5, 5 gives us 5 modulo 7. From here, adding them, we can add them, yeah. 5, 5, 5, 5 to the power 2, 2, 2, 2 plus 2, 2, 2, 2 to the power 5, 5, 5, 5. Directly congruent to 2 plus 5, 7 modulo 7. 7 divides 7. The remainder is 0. And from here, what can you say? This number is divisible by 7. What a relief you get things so. It's so beautifully organized problem. Yeah, I loved it actually. Wow, so beautifully organized problem. I loved it, really. It's a good problem. It is. From this famous little maths little theorem we did. Sorry. So nicely. This part 185 to the power 6 was the most brilliant part I've ever seen in anything. Anyway. So nice. It gives me a sense of relief even after doing thousands of problems like this. It gives me a sense of relief of completing this type of problem. Therefore, was the answer? Is the answer completed? No. The answer is yes. It is divisible by 7. Expect these problems in Olympiads. Expect an animal level questions where you have to do them subjective and show the examiner. Expect this standard problems in JEE. No, JEE is at a very high level. Expect these problems in Olympiads like RMO, INMO, where you have to do the subjective solution and show it. So you'll get the PDF for sure. For sure, you'll get the PDF. And description will be it is there. So that's all for today. Just think 1, 2, 3, 4, 5, 6, 7, 8. We did only 8 in it's 40 minutes. We did 8 slides in 40 minutes. So good it was. Why I really love this. It gives me a sense of relief that it's tips. Yeah, happy? This is where our lecture ends. The lecture 1 has ended. Stay tuned for Euler's torsion function. The next class. Next class we'll discuss, be serious, Euler's torsion function. Then we'll discuss, this is not integration, okay? Euler's torsion function. Then we'll discuss our Fermat's-Lil theorem. Fermat's-Lil theorem. Then we'll discuss Wilson's theorem. Okay, step by step. With this, our number theory part will not end. Then we'll do CRT. No, wait a minute. Yeah, we'll then do PNC, then probability, then CRT. Okay. After doing these 3 theorems and a bit of problems on them, we'll complete it. Okay, so that's end for everything. Goodbye. Good day.